Good evening, student. So in last lectures you have studied about the discovery of electron, discovery of proton, then calculation of E upon m, that's mean charge upon mass ratio of electron, that's mean J.J. Thomson's experiment, and the calculation of charge by Millikan's experiment. After that you can calculate the mass of electron, and I think you have calculated the mass of electron, that is 9.1 into 10 raised to the power minus 31 kilogram. So as you know that in class 10th you have studied about the structures of atom, and in that you told that proton, neutrons are placed inside of the nucleus and electron revolve around the nucleus in a circular path. So today we will discuss about the atomic number, mass number, calculation of neutron, radioactivity, isotopes and isobars. So these will be the topics of today's video. Please see the video up to end, and the question asked in the video you have to solve. It can be conclude that you are understanding the lecture. First heading is atomic number. Atomic number, that is indicated by Z. So dear students, suppose this is a nucleus, and in the nucleus you know that protons and neutrons are present. Your proton is the positively charged particle. It contains plus 1.6 into 10 raised to the power minus 19 coulomb charge. That means charge on proton, that's positive 1.6 into 10 raised to the power minus 19 coulomb. Every atom contains different number of proton in the nucleus, and it is a stable particle inside of the nucleus. It can't be removed from the atom at any case. Neither proton nor neutron can be removed from the atoms. Electrons are moving around the nucleus in a circular path. These are called electrons, and this circular path has a fixed distance, that means fixed radius, and we will discuss in the next lecture about the radius of the atom. So total number of proton present in any nucleus, that means every atom I have told have different number of proton, and it is a fixed number, it is an integral value. So that value is known as atomic number. That means you can say the number of proton present in nucleus of any atom, that will be indicated by the atomic number, and it is represented by the letter Z. Suppose Na atomic number is equals to 11. This means that any atom contains 11 proton at the nucleus, at the center of the atom. And because you know that proton and neutrons are equal in any atom at neutral condition, so atomic number of sodium will be 11, and number of proton in sodium will be 11. Number of electron in sodium at neutral condition will be 11. That means Z for Na is equals to 11. Suppose you take an atom of sodium, so it contains 11 proton and 11 electron. Electron can remove from the circular shell. Electron can be removed out, that means by giving heat energy or by giving any other type of energy. Electron can be lost by the sodium atom. At that time electron may be 10, but proton will be remains 11, and atomic number at that case will be 11. Suppose you lose one electron, So sodium will be written as Na positive. That's mean it is an sodium ion. Sodium ion contain 11 proton and 10 electron. Electron can be less or more in any atom from its neutral condition, but proton will be remain same, either it loss or gain of electron. That's mean atomic number of any atom cannot be changed, it will be fixed. If you have taken one times atomic number of sodium is 11, so it will be always 11, whether it is in the form of ion or in the form of neutral atom. So it is represented by Z. And dear student, if we write any symbolic representation, so atomic number is written below the letter. Suppose you want to write Li, this is lithium, its atomic number is 3, so it will be written here. Another example, magnesium 12 Mg. The number written before the symbols of any element downside, that will be called atomic number. Atomic number of magnesium is 12. Or you can say this is any element X and this is Z. Z means atomic number. In class 10 you have studied up to 20 atomic number. Now in class 11th as well as in 12th you have to study all the atomic numbers of all the elements. That means you have to learn all the atomic number from 1 to 118 or 119. And one more symbol is written upper side of this element here, that is called mass number. Now moving towards the mass number. Okay students. So student, mass number, as you are seeing in the nucleus, proton and neutrons are present. Total number of proton in any atom is declared as atomic number, but the sum of proton and neutron, that will be called mass number. It is indicated by A. As I have told, atomic number of sodium is 11, that is indicated by Z is equals to 11 for Na. Or you can say atomic number of X is Z here. This is only the proton. In the nucleus you will see proton and neutron. Suppose there are 11 proton and 12 neutron. 11 proton, 12 neutron. So what will be the total of this? That will be 23. So 23 will be called the mass number. Mass number of any element indicated the sum of total number of proton and neutron present inside of the nucleus, and it is indicated by A. It is written in above the symbol. You can write like this or like this also, ZXA. And how you will call the symbolic representation? Suppose it is written 6C12. That means atomic number of carbon is 6. Mass number of carbon is 12, and you have to call this representation 6C12. You can write like this also, 6C12. So from this representation you can find the number of proton, number of electron and number of neutron. You are seeing this is atomic number, that means Z is equals to 6. So number of proton, that will be equals to 6. Number of electron, that will be equals to 6, because number of proton and electron will always be same in the neutral atom. Now the mass number, that is A, is equals to, this is A, mass number, that is 12. How you will find the neutron in atom? Suppose this is atomic number, this is mass number, and you want to find the number of neutrons. So you have to write neutron is equals to mass number minus atomic number. So you are seeing this is 12 minus 6, that's equal to 6. That means this contain 6 neutron. Okay student. The symbol of uranium is represented as 92 U238. Its mean atomic number is equals to 92, mass number is equals to 238. So what will be the number of proton? This is the number of proton. P is equals to 92. Number of electron, that's equal to 92. Number of neutron is equals to 238 minus 92. So you will get 6 here and 12 minus 13 minus 9, that is 4. That means 146 neutron in the uranium. Student, when we start from hydrogen, we write the symbol of hydrogen 1H1. This is the first element and the lightest element. What is the atomic number of hydrogen? That is Z is equals to 1. What is the mass number of hydrogen? That is 1. So proton is equals to 1 because this is 1. Electron is equals to 1. And neutron, that is A minus Z, that's mean mass number minus atomic number, 1 minus 1, that's equal to 0. Keep in your mind, hydrogen 1H1 is only the element which do not contain any neutron or 0 neutron. In this way you can find the proton, neutron or electron in any atom. In case of ions, electron can be removed or gained by the atoms, but proton will remain the same and neutron will be the same as in the atom. Now we are coming to the main point why we are discussing this. Before going to the very important topic, you have to do some question. Question number 1. Find the neutrons in 15p31. 15p31. Question number 2. This is 1, this is 2. What is the atomic number of barium? Okay, students. So suppose you want to find the atomic number, mass number by using the symbolic representation you can find. Why we are calculating the neutrons? Here neutron is 0 because neutrons play a very important role in the next topic. Suppose we are writing 6C12. There are 6 proton because atomic number of carbon is 6. Proton is equals to 6. And neutron is equals to 12 minus 6 is equals to 6. Now if we calculate the ratio of neutron and proton, neutron upon proton, so what you will write? 6 upon 6. So it will be 1. What you are seeing at the starting elements from hydrogen to calcium, when you will find the ratio of neutron and proton, it will come approximately 1. You are getting my point? You have to find the ratio of neutron and proton from hydrogen element to calcium. So what you will get? Suppose you are taking calcium 20 Ca40. So number of proton is 20 and number of neutron is equals to 40 minus 20. It is also a 20. So n upon p for this is 20 upon 20, that's equal to 1. But when we move from above element 20 atomic number, that's mean like Above calcium 21, 22, or you have seen example of this uranium 92U238. So number of proton is 92 and number of neutron is 146. If you will find the ratio of this N upon P for uranium 92U238, so 92, that means 146 upon 92, because you are seeing number of neutron in the uranium is 146. On dividing you will not get the value 1, you will get here more than 1. So divide it, and what will be the answer of this? Please write in the comment section. Okay, student? So what you are seeing when you divide these 146 to 92, so you will get the answer 1.586. This is not 1, this is more than 1, and it is more than 1.5. So what you are observing here, as we are moving above the elements from scandium 21 or more, so N upon P ratio, that means neutron ratio proton of any nucleus will increase. If the ratio N upon P ratio greater than 1.5 or 5, that means if we divide neutron and proton and get the answer 1.5 or more, so they are called special categories of element. They are called radioactive elements. Radioactive element. And this will happen in heavy atoms. That means the nucleus of this type of element will be larger and it have high atomic mass like 238. They are not stable, they cannot stand if you will keep like this only. What they do, they want to change this ratio below 1.5. So they evolve some mass from the nucleus in the form of rays. And they emit 3 types of rays, that means 3 types of radiation, and that radiations are called radioactive radiation. So I'm coming to the point, that is what is radioactivity and what is radioactive radiation. The heavy nucleus whose ratio above 1.5, they emit 3 types of radiation from the nucleus of atom and are called radioactive radiation, and this phenomena of substance will be called radioactivity. So there are 3 types of radiation and they are called alpha, beta and gamma. This is alpha, beta and gamma. These are radioactive radiation. They emit from the radioactive nucleus. I am giving you some example of radioactive elements. One is written there, uranium. Why it is a radioactive element? Because this is, you are seeing clearly, its ratio is more than 1.5. So if any element's ratio of neutron and proton is more than 1.5, greater than 1.5, that will be radioactive element. Another example, radium, polonium, actinium, thorium, etc. There are so many elements which show this type of property. They are not stable at normal condition. They always emit alpha, beta and gamma rays from its nucleus till they convert into stable nuclei. So the spontaneous emission, what is the definition of radioactivity? Radioactivity. The phenomena of spontaneous emission of radiation from the nucleus of unstable nuclei is called radioactivity. Who discovered radioactivity? Madame Curie and her husband Pierre Curie discovered this radioactivity and got the Nobel Prize for this. And what are radioactive elements? The elements which emit radioactive radiation will be called radioactive elements, and the examples of radioactive elements are radium, polonium, actinium, thorium. The ratio of neutron to proton in these elements will be more than 1.5. What type of radiation occur? These are three types of radiation emit from radioactive elements. This is alpha, beta and gamma. In these three radiation, gamma radiation is most harmful and causes dangerous disease which cannot be cured. So student, today it is enough. Tomorrow we will discuss about the properties of alpha, beta and gamma and how the radioactive elements will be converted into stable nuclei. Before closing this video, you have to write some question. Question number 3. Find N upon P ratio in 1H3. Question number 4. What is radioactivity? And now you have to do this question, submit this question on my personal WhatsApp number. We will meet again same time here. Good night.